In this video, we will discuss about swarm intelligence, that is a problem-solving approach inspired by the collective behavior of social organisms like ants, birds, and fish. Swarm intelligence is a field of artificial intelligence and optimization that focus on how decentralized individuals, like the individuals in natural swarm, coordinate and cooperate with each other. So here we have different key characteristics of swarm intelligence like decentralization, self-organization, emergent behavior, robustness, and swarm robotics. So first one we have decentralization. In the swarm intelligence system, there is no leader or control system. Instead, individual agents such as insects or robots, they follow simple rules and interact with their neighbors. So we have no leader or there is no control system. They follow simple rules and interact with their surrounding and neighbors. Next feature we have self-organization. Agents in swarm self-organize by responding to local information and the behavior of other agents. Through local interaction, global patterns and behavior emerge. Next we have emergent behavior. The collective behavior of the swarm emerges from the interaction of its individual members. This behavior can be complex and adaptive, allow swarm to solve variety of tasks. And the next one we have robustness. In many cases, swarm intelligence system can survive the failure of their individual agents. System can still work even if certain members disappear or stop working. In the last one we have swarm robotics. This field applied swarm intelligence concepts to a group of robots that work together to achieve common goals such as exploration and environmental monitoring. Swarm intelligence systems have been applied to a wide range of optimization problems. For example, optimization of routes, search and rescue, distributed computing, finance, healthcare, and many more. So as we already discussed in previous video about optimization problems, what is meta-heuristic optimization, what are design variables, constraints, objective function. Then we have optimization problem classifications and different types of optimization problems, discrete, continuous, linear, non-linear, and other. Now, after problem formulation, we will discuss the search for optimal solution. So once the optimization problem is formulated accurately, our aim is to find out the best solution, that is the optimal solution. For that, first we need to accurately formulate the optimization problem. Here you can see we have generic linear programming problem where we want to minimize an objective function which subject to different constraints. Next we can see here optimization problems, key components, objective function, design variables, constraints, feasible reason, and optimal solution. Objective function that is mathematical expression define what we want to optimize. Either we want to minimize or maximize. Next we have design variables. Design variables are the parameters that we can adjust. In simple words, we can say design variables are the decisions that we make to reach the optimal solution. Next we have constraints. Constraints represent the limitations and requirements that must be satisfied for the solution to be valid. So we can use different equations and inequalities and define the boundaries of feasible reason. Next we have feasible reason, that is the area. The last one we have the optimal solution, that is the best solution. So our goal is to find out the optimal solution within the feasible reason. Optimal solution is the combination of design variables value, either minimum or maximum. So once the optimization problem is accurately formulated, our aim is to find out the optimal solution. and we can solve optimization problem using different methods or algorithms. So we have different methods used to solve any optimization problem. First we have brute force. This method examines all possible solutions. The next one we have greedy algorithm. Greedy algorithm make local optimal choices at each step. In the next one we have heuristic algorithm that use approximation technique or rules of thumb. And the last one we have meta-heuristic algorithms. Meta-heuristic algorithms employ advanced search techniques like genetic algorithm and other. So we can further classify optimization algorithms as deterministic algorithm and stochastic algorithm that we already discussed in previous parts. Stochastic algorithms further classified as heuristic and meta-heuristic. Heuristic means to discover by trial and error, but there is no guarantee that the optimal solution will be returned. Next we have meta-heuristics. Meta means beyond, or we can say higher level. Meta-heuristic algorithm often perform better than heuristic algorithms. So here we will try to understand how meta-heuristic algorithms work. So once the optimization problem is formulated accurately, our aim is to find out the optimal solution. Now we will try to understand this using an example. Finding best solution is similar to going treasure hunting, where we have time constraints. It means we have time limit and we are searching large area for hidden treasure and we don't know where it is. Now suppose we have large area and you have to find out here the hidden treasure, that is this one, but you don't know where it is. So in order to find out this hidden treasure, you have to explore and dig. Explore this entire area. So here our goal is to find out this hidden treasure. So this is the optimal solution. So here the optimal solution lies in this area, and when you are exploring this area and instead of gold coins you find out stones and other things, they are not the best solution. We can call them worst solution. Now we have time constraint. So there is time limit. You have to find out this hidden treasure before sunset. Now you have to explore entire area. So here this individual will start the search by random walk in different direction and looking for the hints. Randomly explore the area and digging here there to find out the treasure. It's similar when we search for the lost thing in the room or in home. Now when we are doing the random search alone, here and there we are digging and searching for the treasure. We have two possibilities. In the first case, when you are digging somewhere in the area and you find out gold coin, that is hint, and start digging around. In second case, you are continuously digging here and there but you are not getting any clue or any hint in particular region, then again you have to move to another area to dig and so on. But here we have time constraint. We have to search the treasure before sunset. Now in this case how we can find out the optimal solution. Next, so here we have solution. So now we have solution here. Suppose now instead of one individual we have a group of friends who are searching for the hidden treasure in that area. So first the group will divide the land into different sections. Now here you can see this land is divided into 5 sections and each friend is responsible for search in that particular section. So when we divide the land into different sections, we can search efficiently. Now you can see when the land is divided into different pieces, search is now more efficient. Now we have time constraint, that is before sunset. So maybe there is a possibility before sunset they can easily find out the treasure. Now how they will search? Suppose they are digging in their sections. Now you can see the search process started here. You can see the digs. These are the digs that the first individual perform, second perform, third individual digging, fourth one and the fifth one. Now in each section each individual start digging. Now in case if any friend find out any clue, then this friend will share this information with other members. And then we have combined efforts. Now suppose this fifth friend find out some gold coins during digging, so he share this information with other friends. Now they all will make here combined efforts, that is the teamwork. Now they gather at the spot and start digging together, and by working together, sharing information, by combined effort in group, they find out the hidden treasure. After teamwork and with their combined efforts, they find out the hidden treasure in that area. Same this is done in the Meta-heuristic algorithms. We have a search space. Suppose this is the search space, or you can say this is the feasible region where the solution is, where the optimal solution is, and we have to find out the optimal solution. And we can use number of search agents, or we can use few number of search agents. For example, in particle swarm optimization algorithm, a group of birds, they are searching for a piece of food in a particular area, but they don't know the exact location where food is, but at each iteration they know how far they are from the piece of food, that is the optimal solution. And in this example, you can see here they interact with each other, they share information. Like in Metaheuristic, we improve search agents, we update agents position around the best agents, and we improve the worst one. So randomly solutions are generated in an area and they update their position. In the end, they return the best solution. Now we will apply meta-heuristics to solve real life optimization problem. So we have different steps. First, problem formulation, identify constraints, then select meta-heuristic, define objective, select meta-heuristic algorithm which you want to apply, define your objective function, initialize the population randomly, then apply meta-heuristic. After that, check the stopping condition, compare and improve the solution, analyze result, parameter tuning, and test run on specific problem. So here we will apply ant colony optimization algorithm to solve traveling salesman problem. So here we formulated the problem, that is traveling salesman problem, identify the constraints, select the meta-heuristic, that is ant colony optimization algorithm, define objective function. Our objective function is here total distance travel in a tour. So we will calculate the total distance and then we will select the optimal route. And after that, initialize the population, apply meta-heuristic. Ant colony optimization algorithm we already discussed in previous video. For more detail, you can check this. Now we will discuss just the key points. So now we will apply ant colony optimization algorithm to solve traveling salesman problem. Suppose we have here 5 cities A, B, C, D, and E, and we have 4 ants, first, second, third, and fourth. And you can see the distance between each city from A to B 10, distance from A to C 20, A to D 50, like that from all cities. After that, we will initialize the pheromone levels on each route. So for example, we will take 0.1 pheromone level on each route. After that, we will apply the meta-heuristic. So first we will do parameter setting. We have alpha value 2, beta 1, pheromone evaporation rate 0.3. Now we'll search the optimal solution by the iterative search. So how we can apply ant colony optimization algorithm to solve traveling salesman problem we already discussed in previous video. In this video, for more details, you can check this out. Initially, each ant will start its route from A, and to select next city, suppose ant 1 start from A, then probability of ant going to city V is this one. Using this equation, the value is calculated. Probability of ant 1 to go C to C, this one to D 0.067, to E 0.034. Now the first ant completes. This route. You can see A to V, C to D, D to E, and A to E to A. So the total distance for this we have 76 units. After that, for second ant, you can see the route is calculated here. A to B, B to D, D to E, E to C, then C to A, and the total distance for this route we have 94 units. For third ant, when it's completed its route, A to C, C to B, B to D, D to E, E to A, and the total distance for this tour we have 103 units. For the third ant, the tour we have A to E, E to B, B to C, C to D, D to A, and total distance we have 94 units. So here among all, you can see for the first ant it is just 76 units. So total distance for this is minimum among all. So this is the best for first iteration. Now after that we will update the pheromone levels, then we will check the stopping condition. Until the stopping condition is met, we will repeat the loop, and then we will compare and improve the solution, analyze results, parameter tuning is done until you obtain the optimal solution. Then perform run test on the specific problem. So these are the simple steps for applying any meta-heuristic for real-life optimization problem. We just applied here ant colony optimizer on TSP. You can use any algorithm and any real-life problem. Just follow the steps. First, problem formulation, identify your constraints, then select any meta-heuristic that you want to apply. Define objective function, initialize the population, then apply your meta-heuristic. After that, we will repeat the loop until the stopping condition is met. We will compare the result, and we can improve the results by parameter tunings, and we can run different tests on the specific problem we obtain till we obtain the optimal solution. So we are using Swarm intelligence to solve different real-life optimization problem to find out the best solution. So that's all about this video. If you have any questions, you can comment below, and thanks for watching this video.